Okay, so we're doing example number 13 and example number, no, 13 and 14. Okay, so similar to what we have done before, you need to check how many logs on both sides. Okay, so you have 2 logs here, no log here. So this is a combination of situation 3 and situation A, right? So situation C, that means you have multiple logs on one side of the equal sign. You kind of need to combine them first, okay? So let's do that. I'm gonna make another example here, log 7, 2x plus 3, plus log 7, 3 equals 5, okay? So you have, count again the number of logs on each side of the equal sign. 1, 2, nothing. Okay. So if you have 2, therefore, though you can only solve at least manually, okay, logs if you have 1 log on either side of the equal sign or no log at all on the other side, but you can have multiple. You can use it if you are using a calculator or a computer, but if you want to do it manually, then you have to combine them. So we have to do that. So you have 2 in here, and then you have a plus sign. So that means these 2 argument needs to be multiplied. Okay, so I'm going to copy that, log 7, and I'm going to multiply this 2. This is a binomial that's monomial. So I'm going to start with 3, 2x plus 3 equals no log, so just copy 5. Okay, so when we get to this point, so this is the problem. When we get to this point, well, how many logs? 1 log, no log. So now this is like example letter A, right? So in this case, you need to change this into exponential form. Exponential form. This is the base, 7, exponent, and this is the argument. Okay, so now we do 7 to the power of 5 equals 3, 2x plus 3. Okay, now I don't have a calculator with me, so I'm going to change this 5 right here. Okay, I'm just going to change it to make my life easier. So let's pretend that my problem here is just this. Okay, so oops. I'm changing the problem so I can solve it easier. Okay, so this is original problem equals 2, and so now I will have base exponent, so 7 to the power of 2 equals all of these as my argument, that one. Now, what is 7 squared? That is 49 equals, distribute 3, so you have 6x plus 9. Gonna subtract 9 on both sides, so you have 40 equals 6x divided by 6 divided by 6. Therefore, your x is going to be equal to 20 over 3. Use your n over d to simplify it for you. Okay, so that's like number 13. Okay, let's move on to the last one, which is similar to number 13 pretty much. Okay, check again the number of logs on each side. 1 log, 2 log, nada. Okay, so this is similar, basically just like number 13. Okay, but just a little bit more complicated with the argument part. Okay, so let's do that. So I'm gonna do another example. Log 2, 3x minus 2, plus log 2, x. Let me change it to, so it's pretty close. 5 minus 2x, and then 8 plus 3x equals, let's do 5. Okay, so now we will combine again. If this was minus, then you will divide this 2, but this is a plus, so therefore we will multiply, right? So let's condense this. Let us condense this. Log 5, log 2. Okay, multiply. So you have 5 minus 2x, 8 plus 3x equals 5. Okay, so now this is like situation A, because you have 1 log, nothing here. So we need to change this one to exponential form. Okay. All right, base, exponent, all of these arguments. Okay, so 2 to the power of 5 equals 5 minus 2x, parentheses, 8 plus 3x, parentheses. All right, 2 to the power of 5 is 32 equals, well, this is binomial times binomial, so we will have to multiply them. That means 5 times 8 and also 5 times 3x. Let's do that. 5 times 8 is 40. 5 times 3x is 15x positive. Next, let's do negative 2x times 8 and negative 2x times 3x. So now negative 2x times 8 is negative 16x. Negative 2x times 3x is minus 6x squared. Okay. All right, let's simplify the right side. 32. I'm going to change this one back. 32. So you have 32 here, combining like terms. So I have 40. These two are like terms. So I have 40 minus x minus 6x squared. Okay. Now, if you look, if you see the highest exponent is 2, the degree of this equation is 2, so therefore you need to set it to 0. So I want my x squared to be a positive, so I'm gonna copy that in here so we have more real estate. Okay, so what I'm gonna do is I'm gonna add 6x here. That's a negative, so I'm gonna add x. That's a negative, so I'm gonna add 4, and I'm gonna subtract 40. And I'm gonna do the same thing here, negative 40 plus x plus 6x squared, okay? And the reason is that I just want my right side to be 0. So that means this will be gone, that will be gone, that will be gone. I'm gonna put the equal sign here, that's 0. Okay, so now you have 6x squared plus x, 6x squared plus x, and then negative 40 plus 32, that's minus 8. All right? Okay. So now we have to factor this, okay? Now, this is a little bit harder to factor at this point, but your example is easier. The reason being that a here is not equal to 1, okay? Not that it cannot be factored, it's just that that's the problem is you're just making up equations. Okay, so I could use quadratic formula to solve this, or I could use this thing right here. I'm not gonna show it in here so that it's not very, very long, okay? But basically, after you get this, you just factor it out. So if we pretend that this problem right here, okay, let's just pretend that when you do this, your answer becomes x squared minus, I don't know, minus 10 minus 3x equals 0. Let's say that's the simplified version of this so that we can easily factor it. So now you have that, right? So you're gonna put negative 10 here, and then you're gonna put 3 here. You need to think of two numbers that when you multiply will give you negative 10, but when you add will give you negative 3. So that will be negative 5 and 2. But negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. So now you have x minus 5 and x plus 2 equals 0. And solve for each one. X minus 5 equals 0. X plus 2 equals 0. X equals 5 here. And then x equals negative 2 here. Okay. And then, of course, you need to substitute these values in here to see if there's not going to be any error. Okay. Now, this, again, is an assumption that this answer, the simplified version of this is that I just did not use it because it cannot be factored easily. Okay. And that's not really the point of what we're doing. Okay. If you have any question of this one, just message me and I'm gonna make a better example. All right, see ya.